Hello, Dr. Xian. Welcome to our group project presentation, Hotel Booking Prediction. Our team members include Mei En, Sok Qi, Wei Lai, and me, Cai Jue. Our presentation will be divided into 8 sections. Here is a table of contexts. Our project invests in the significant impact of hotel booking cancellations on revenue and operational strategies and employs SEMA methodology with associated rule mining, sequence analysis, and deep scans to analyze and improve hotel management and booking systems. The specific objectives include 3 key areas. 1, developing a predictive model. 2nd, in-depth analysis of customer behavior. And the last one, strategy formulations and management optimization. The original dataset contains 119,390 records with 32 variables, broadly categorized into 5 types. Let's now dive into our dataset using SEMA. In the group assignment, we provide a detailed explanation of metadata and reclassification. Considering further explosion of the model and additional software explosion of the dataset, we used the reclassification setting in SAS to obtain a 20% random sample of the data. It can be observed that the target variable into the dataset remains. From the sample data, it can be observed that many reservations were cancelled, with the majority of guests being short-term tourist travels, and the most popular months may be being July and August. Guests often from distant locations and may enjoy leisure travel. Here is a specific distribution of missing value in our dataset, and we will discuss and address them in detail in the modify section. The tri-square study indexes that reservation state, sport type, and market segment as the top 3 variables strongly correlate with the booking cancellations. This will make sense in the model section. Reservation status, sport type, and lead time are highly informative and closely related to the is cancelled target variable, where other variables may not serve as effective dependent variables. So next part, let's invite Mei En.
My name is Mei En. I'll be talking about bivariate analysis first. So as you can see, Resort Hotel has a wide range of ADR, but fluctuated. City Hotel has a more stable ADR. This scatter plot shows that ADR is lower when the time is longer. Also, we see that August is the peak season, and that 31st of the month usually has global summer of bookings. The cancellation analysis shows that longer the lead time, the higher the possibilities of cancellation, as shown in the City Hotel. You also see that customers are more willing to make the reservation when there's no deposit requirement. We also found that total ADR of confirmed booking is higher than total ADR of cancellations, so losing revenue on cancelled reservations. Also, multivariate analysis shows that highest revenue in the summer holiday months, and that the price is always a concern for people. These are some of the preferences of the people. And we also see that cancellation booking of 2 adults without children increases when staying night for more than 10 days, and cancellation booking of 2 adults without children is the highest when that time is more than 300. Also, that transient customers who book the hotel with non-refund will cancel booking eventually. So changing plans and unforeseen events being a factor. This is our modification plan, so we'll be addressing we address the missing values. Also the invalid values in meal. We'll also be correcting the inconsistencies and the noisy. For the noisy data, we'll be retaining the outliers because they are more representative of the real world scenario, and we'll also create a unified check-in date. So as you can see, in meal variable, the UN was replaced with SC because they mean the same thing. And Asian company, they are yes replaced to 1 and no replaced to 0, and all months were corrected. And we created a new variable containing the complete date of customer check-in at the hotel. And for data cleaning, you can see that the default median imputation for interval variable was median. And for the class variable, it was tree surrogate input because, for example, reserved room type can be used to predict assigned room type. So tree surrogate is a better option. And for the summary of imputation, you can see IMP prefix followed by the imputed variable. And the imputed value, for example, ADR replaced with 95. And that's how we did our data cleaning.
I'm Sophie. Now I will continue with modeling and assessments part. Before we proceed with modeling, we perform data normalization and data partitions. So Z-score standardization has been used to normalize those numerical type of data to reduce skewness, and data has been split to 70% of that training set and 30% of validation set. Firstly, we construct a decision tree with different layers. By doing this, we are able to know what is the different model performance between different layers. So we can see that decision tree with 2 layers are the worst model. However, when the number of layers are increasing, the misclassification rate is decreasing, which means then that model is improving when layers is added. So the deposit type, totals of spatial requests, market segment, previous cancellation, and also lead time are important variable when constructing decision tree. So gradient boosting is primarily used for classification, which is specifically a type of boosting method, and it can also reduce risk of overfitting. Gradient boosting achieves the misclassifications rate at 0.189. So we can see that the variable importance is quite similar with decision tree, proving that it is combining decision trees from a more powerful composite model. So moving on to the random forest, it is a powerful machine learning which belong to bagging category and also can handle the underfitting issue. So in this case, we can see that the misclassification rate is achieving at 0.1874. Variable important evaluations are a bit different with decision tree and gradient boosting. It is using number of splitting rules and also Gini reduction to evaluate the variable importance. A higher number of splitting rules and a higher value of Gini reduction, indicating a higher the importance of variable. So although the evaluation metric is different, but we can see that the variable importance are similar with other models. So moving on to the logistic regression. Logistic regression is a statistical method for predictive analysis and is a classification algorithm used to solve binary classification problems. So 0.19358 of misclassification rate is obtained in logistic regression, and the result of odd ratio estimate are shown here as well. So 9 numbers of neural network with different hidden uniques are trained with our data set. The top 3 models with the lowest misclassification are the number of hidden uniques of 20 layers, 5 layers, and also 25 layers. So moving on to the assessment, random forest is the best model among all traditional machine learning. Not to mention, even we have constructed the decision tree with different layers, the decision tree is having the poorer performance compared to other models. As I mentioned in previous part, neural network with 20 hidden uniques are the most performed model, closely followed by neural network with 5 layers and also 25 layers. So in this session, we have chosen the best model from traditional machine learning and neural networks. So we can see that the neural network with 20 layers and random forest are outperforming among all models. Notable, the differences of misclassification rate between training and validation are not much, indicating that all predictive models are good fit, although the complexity of the models are increasing. Variable importance like the deposit type, market segment, lead time, previous of cancellation appear frequently in different predictive models. To summarize it, as our original dataset have total of 119,000 records, which are a very heavy dataset. Hence, neural network models is the best choice of hotel booking prediction models. So next, I will pass the floor to Wei.
Hi, Dr. Tay. My name is Wei Lai. I will present association rule mining and sequence analysis. Association rule mining is used for market basket analysis to identify the pattern, while sequence analysis is used for provide and understanding sequences of user behaviors. The evaluation metrics such as support, confidence, leave are used in association rule mining, while most common product or service sequence are used in sequence analysis. For the association rule mining of MIL, we have set the threshold of support and confidence at 60% respectively. So from the table, we can see rules BB to HB and rules HB to BB exceed the threshold. And in this case, we can optimize the layout of the website or mobile apps by featuring the HB as the primary option, BB as the second options, and subsequent choices. For the association rule mining of reserved room type, we can see rule D and D to A and rules A to D have exceed the thresholds. So in this case, we can offer the room D and A as a bundle package during the seasonal holidays. This is to target customers with larger families who may require multiple rooms. For the sequence analysis of meal, we have count the sequence length of 2 is 13 rules and sequence length of 3 is 33 rules. This indicating many customers rebook the meal type 3 times. So in this case, it could be due to the booking system have an issue that caused the customer to repeatedly book the meal type. For the sequence analysis of reserved room type, we have counted the sequence length of 2 is 30 rules and sequence length of 3 is 65 rules, indicating many customers rebook the room type 3 times. So the fluctuations in the hotel price lead the customer change their room type booking multiple times. We have also done the customer segmentation in KNIME with the DB scans. So from the scatter plot, we can see cluster 3 has a tendency to book the hotel with a longer lead times. So in this case, we can offer exclusive early booking discount to them. While for the rest cluster, they engage in last minute bookings with higher room price, we can implement dynamic pricing strategy to them. In conclusion, we utilize many tools to develop a predictive model that can predict the hotel booking cancellation accurately and to uncover the valuable insight into the customer preference and behaviors. So by incorporating this, the hotel management can formulate an effective strategy to enhance the revenue. So this is our contributions, and that's all from us. Thank you.